Hey, everybody, welcome back to another Transformation Leaders podcast episode. I'm David Soden, your co host, and joined today with Sean Ennis. And together, we're going to cover another really great, interesting topic for you, talking about intent engines. And Sean has gone through and did a lot of homework to put this demo together for you. And so I am going to hand it over to Sean, and we're going to bring up a deck for you so that we can kind of go through each and every one of these. But just before I officially totally hand everything off, just want to let everybody know that we're here every Wednesday at 12 o'clock noon. And this is another addition to the RAG. We've been kind of hitting on this the last couple of weeks, but there's so many different new technologies and approaches and discussions about all of this. Don't be surprised if you see 50 more because of all of the changes that's happening in the industry. And Sean can kind of allude to a little bit of that and what he's going to show you here today now.
Thanks. So one of the things that we talked about last time was RAG, which is a way for you to take your data, augment the large language model so that you can get new answers. And the example I used last time, we saw the accuracy wasn't that great. One of the major things that we got feedback for was, why don't you just try a BERT model? And now, most of you probably never heard of what a BERT model is, but I would implore you, if you have ideas, please drop a comment. If you don't understand or you have why didn't you do this? Why didn't you do that? We want to hear from you. And we want to show how easy it is to explore this so that for the non-technical people out there, you understand what the technical people are doing. For the technical people, that AI can really help you accelerate these things. So let's take the next step. In this use case, I want to talk about conversing with your data using intent engines. So let's talk about what conversational analytics are and what intent engines are. So conversational analytics is when you have a group of data and you want to ask questions about that data. So for example, I have a database that may have a list of all my employees. And then I have another database that shows for my applications what kind of access people have. And then another database that shows what people are doing on the application. And I have those three sets of data. And what I want to do is I want to ask it questions. I don't want to hire a business intelligence person to create me a dashboard. I want to ask a human question, and I want AI to create all the necessary APIs or database calls to grab the necessary information, combine it, and give me a response. This is what conversational analytics is. And to do that, you need to do something called intent discernment. Again, technical people like to make things so much more difficult than they are, but the intent discernment is, what are you trying to do? WTF is the question, right? So when somebody is asking you a question, you need to be able to determine, where do I get that answer? And that's what the intent is. So if I ask a question about how long has this employee been employed? Well, it can go through and it knows to hit the authentication database and says, how long has this employee had a login? And it gives you that answer. Well, I don't know, but they've had a login since this date. And you say, okay, what have they been doing for the last 10 months? Well, it can go and pull back the logs, take the person's name, figure out what's its username, and pull back a list of all the user logs, combine it, summarize it, and give you an answer. And that happens behind the scenes. So that's what an intent engine in this concept with conversational analytics does. Now, certainly you can use a RAG model, right? And we talked about that last time, which is basically a Hail Mary. I'm going to just try to take all my data and load it up in a RAG model and get an answer. Well, you could do that. We showed you could do that. The question is, how accuracy would it be because of the conflicting data? So the next, using large language models, it really doesn't have your data in there. It doesn't have every query that you would know. It would know how to create a query. And maybe that's fine. Maybe the APIs or the databases that you're talking about are free public knowledge and you don't need to do anything like that. Or what we're doing here today, which is I want a bespoke intent engine, meaning I want to take the open API Swagger document and I want to train the model on that Swagger document and all the different possible queries you can have. So I'm going to take a pre-existing system where people have put in all the kind of questions that they want, get a list of what all the answers should be, and I'm going to load it into a model. So effectively, I'm creating a small language model or an intent engine. So I know that was a long way around, David, to get us to what a small language model is in this use case. But it did make any sense?
All roads lead to the language model.
Yeah. I mean, and through this, I wanted to place in everybody's mind this concept, which one of the podcasts that I listened to talked about recently that really resonated. It's called the AI Bitter Lesson. David, have you heard about the AI Bitter Lesson? And you could see it was posted on Twitter a couple weeks back. And it's essentially that it used to be when you wanted to do a machine learning project, what you would do is you get a group of really, really smart, intelligent people to come up with a way to create a very bespoke model to do a very bespoke thing. And you limit down the scope, and then that increases the accuracy. And the flip side is that you can just take everything you have, flip it to AI, and have it figure out the best way forward. And the bitter lesson of AI right now is that 10 times out of 10, throwing everything to AI and telling it to take the most optimal path is the easiest and the best accurate result. And so that humans being part of the design process is showing to be less and less valuable, which this is the bitter lesson of AI people are running into, is that brute force and ignorance is now becoming more and more of a valid approach. And so wanted everyone to understand that concept as we move forward with this. So any questions before I kind of start explaining what was done here to kind of show how to build intent engines?
Just curious, from my own perspective, when I've had complicated things, obviously, so at least these are the way I compartmentalize it when I'm faced with either a project or having to deal with a data set. I'm trying to figure out is, do I need to just train it on information where that information is contiguous to the point of where, I don't know, if I group it in chunks of, I don't know, 100, 500, 1,000 characters, whatever that might be, versus say, and that's the RAG model, right? You're chunking it and you're vectorizing it, versus say you're trying to get information where a CEO, a COO is wanting to know information about specific information and data. So what I've seen in the past is if you're trying to do a search query on referential data because it's just about knowledge or general knowledge, RAG is good. if you're looking at something that's has logic behind your question, where you're asking it to say it needs to filter the answer in some way because you're giving parameters. So if you find yourself saying this week, this year, this whatever, that means that there's a data set somewhere. And at that point, RAG, just to be candid, sucks. It gives you junk, garbage information. So what's the difference in the approach that you're talking about here with intent engines? I almost see it as almost a third pillar, a third tier, versus query-based, just leaving it in a database, but having an AI agent versed in SQL, knows how to query SQL, understands the schema, can translate the natural language question into its tooling arsenal and says, do I need to go to the RAG engine for supplemental knowledge base here to answer the user? Or is the question about some data that I know that there's a data set and I can simply just provide a query? I guess it's a kind of a multi-stage question too, especially when we start talking about agentic AI and tooling and things of that nature too. But is this a third method of applying? Yes. That's what it feels like to me.
Yeah, I mean, it is as close to machine learning as you can imagine. So let's jump into a nice, good diagram. I'm a techie. I like diagrams, so dynamically discerning intent. So a person here on the left or a group of people ask a question, and how do we get that answered when we have this data lake or APIs available? We need to be able to take a question, understand what data sets are available, how to query them, get a subset of that data in real time, pass it back, construct the answer. And this is what I'm trying to build, right? This is what conversational analytics are. The difficult part is, how do I look at a question that anybody can write, whatever question you can think of? So if you're talking about, users and accounts and logins and user activity, and then you ask about zebras, right? What's going to happen? You need to be able to handle this. You need to understand and put all the necessary guardrails to make this possible. And walking into this, I was like, okay, this is a pretty straightforward problem. What if I can just throw AI at it? RAG worked pretty well. At least it was functional. It certainly showed that you needed to invest more time in reviewing and chunking the data better and maybe providing more sets of data. But it certainly showed that. So pretty safe to understand that on the right, there's data sets that says, here's the data, they're in these formats, there are these table schemas, it's using this querying language, this is the APIs to access them, the usernames, passwords. You showed that with I believe it was a MongoDB very, very early, 3 months ago on this. Now the APIs are going to be RESTful APIs. What are login and authentication for that? All that has to be defined as context to any kind of intent engine. And the end result is, once you have the subset of data, if you query too much data, the context window will overrun and you won't get an answer. So this is an incredibly important problem. You need to query the right data and just enough of it to get your answer. You need to be able to detect when the data is too big so it doesn't query too much data. You need to make sure when people ask a question like, hey, what color are zebras? Well, that has no context of what we're trying to accomplish here. I'm going to do nothing. So this is a really good example of having a guardrail. It's a really good example of what context and prompting, and it is the definition of multi-shot, because I am going to take the question and I'm going to find out what data I should get. Then I'm going to get the data and the question and then query again and say, okay, how do I answer it with this data set? It's 2 shots. So you need 2 prompts, right? So with all things AI, you have to start on the equipment side. I am building this from scratch, certainly, and we'll talk about if you were to use a cloud provider, what would you do? We'll get to that soon. But what I'm doing is I tried to do this on the little NanoPi I bought last time, and it decided to run for about 3 days and do nothing. So hardware is certainly an issue. I tried to do this with raw CPU cores. Again, 14 cores, 64 gigs of RAM, a $500 mini PC, and it cooked and cooked and cooked for 15, 20 minutes. And we'll show what the end result was. So that I broke down and I bought a dedicated GPU, which is about $1,100 on Amazon. I got it on Amazon Prime Day, so much, much cheaper. But I used Olama and BERT. So BERT is your bottom transformer. It is, if you've ever been auto-corrected on a text, you've interacted with a BERT model. It's very rudimentary. It starts at what words are, and it doesn't really have any knowledge to it. So you're just building on top of a dictionary, if you will. Very rudimentary. And what I did was I generated about 100,000 prompts with appropriate answers. How I did that was I used Olama. I said, here is the APIs. Come up with 100,000 queries, and let's use that data to train a BERT model. And it cranked away on it. And after a couple of days, I had my data set that I could push into the BERT model. So David, does that make sense?
Yep. With you so far, tracked 100%.
So now I go and I ask, I want to build a script on Ubuntu that takes a directory of the JSON files I just created, and I gave it the format of what the training data would be. That's going to determine which APIs and what parameters should be used for the user query. The output should be a Python API script running on a port that leverages the BERT model created. I want a test harness to use a second set of data. Remember, if you're going to create training data, you need to create test data. And provide me a script that creates the model. Start by providing me a bash script that installs all the necessary libraries. I'll be honest with you, it took longer to install all the necessary libraries and applications to do the training and hosting of the API than the actual training of the data.
Dependency hell. Welcome.
It basically, it had to compile Python from scratch.
Yeah.
So if you run into your machine learning data scientists, give them a hug. They deserve it. This is not something that, I mean, again, I did the RAG model and it worked off the shelf. No problem whatsoever. This, I had to reinstall my Linux twice because the dependency hell that it went into. So, you know, again, this one is probably more complicated. I know somebody out there is going, Sean, I got an even better one to make you do. And we'd love to do it. We want to show how deep this goes. But it showed that basically 32 times faster, that the GPU could execute 32 times faster. Now, if I go back to this cost, this is only twice the cost for 32x the value. Now, before I did this, I was really wanting to know, this GPU cost $1,000. Is it really worth the cost? Well, if you buy 32 of these, that's 16 grand. So, there's a reason why everybody is buying these dedicated GPUs. There's a lot of cost efficiencies in these. So really, really interesting value, but you could see that it basically took 2-3 minutes with a GPU. Really interesting note, I had to put a new power supply unit into the PC to be able to handle it. It required three power plugs into the GPU. And when I turned it up and I started doing this training, my UPS started screaming because I was using too much power and the UPS was being overwhelmed. So I had to buy a new UPS. So again, super interesting. If you want to know why your power costs have gone up, you might want to look at see how many AI data centers are in your neighborhood. Because they use a lot of power to do this type of work.
Did your local law enforcement office can't reach out to you and contact you because they thought maybe you were invoking a grow house in your basement?
No, fortunately, I'm in Texas. They don't worry about that. So
you got different power problems over there.
Exactly. As I said, it was 32x. The training took 29 seconds for 15,000 parameters. As I said,
Crazy.
It took about 2.5 minutes for 100,000 parameters. Now, you've probably seen us talk about models, and at the end of the model name, it said like 8B or 32B, BP. So billions of parameters. So most large language models are in the 8 billion parameter. This is 15K or 100K. So you can get a good understanding. Exactly. I mean, what I did, and I want to make sure everyone understands, you can do this too. It wasn't that difficult. If I can do it, you can do it. I built and I followed the same method as anybody else who makes large language models. Now, I'm sure they made it better, as you could see with the testing. With 15,000 parameters, I got up to 17% accuracy, and I added 10,000 more parameters to that, and I got to 18%. Eventually I started getting into the 100,000 parameters, and it still did not impact the accuracy very well. And there's plenty of rooms for that, but the testing accuracy showed that this is not just pumping a whole bunch of data and it works.
Yeah, no, you have to have different unique data because the vectors just repeat after a while, and the output will, like you just said, the amount of parameterization or inputs that you're putting in is there, but the uniqueness of the data, it doesn't create a unique enough vector. It's so minuscule that your accuracy,
it actually causes hallucinations, is what I saw. So the learnings that I had is the quantity of data is not important as much as the diversity of data. And so, people talk about the 4 V's of data, they matter. And if you think that creating data with just using a large language model to create data is going to create everything that you need, it's just not true. Now, can you capture that data and have a pre-existing system so you can ask people what questions and manually create that data? Yes, you can. We talked about ground truth last time. And so there's lots of things that you can do. But what I found most truthful of all of this was perhaps the best thing you should do is just write a prompt explaining what the query should be. So a large language model with really good GPU and a really good reasoning engine built into it with the prompt, and it can be a low parameter, but you can, and that's the solution to this. So the solution came full circle that yes, you can do this. There are many products out there that do conversational analytics and help you with your conversational analytics. But what I've found is going to this degree, it doesn't increase the accuracy. It doesn't increase the performance. The best possible solution is actually using a large language model and putting the knowledge in the prompt of here is the Swagger model, here is this, and creating and using a large context window like 100,000 tokens, and using the large language model as the intent engine so that instead of 2 shots, it'd be 3 shots. The first shot would be, I'm going to take it and I'm going to get the parameters and APIs. I'm going to take that, do the query. I'm going to thirdly go back and then construct using the data. So the data is what drives the accuracy. I want to make sure getting high quantities of data is not more important than high veracity of data or diversity of data. Yeah. Manually curated data to make sure it's right so that you're not creating hallucinations. And then testing and constant iteration. So if you wonder why it takes so long to build these, it's not because it takes GPUs to train them. It does. It's all about the data. And it's always been about the data. And, you know, on that bombshell, that's really what I wanted to cover today. David, what do you think?
No, I think it's great. I think one of the shows that we should consider too in the future, and, you know, folks, if you're hearing this, go ahead and leave some comments in the comment boxes below these videos so that Sean and I can monitor them. Also on our website, there's a form, so fill that out, and then you can send us in communication. You'll get us both at the same time if you do it that way. But I think at the end of the day, this just got me thinking about something that I did create even recently. Some of it was for work, other kind of just more curiosity. But it was me taking a schema. So somebody had a database. What I did is I reversed engineer it. I tore it apart. I got the schema. I fed the schema to AI with the intention of creating an agent that specifically did nothing but this database. And said, here's the database. Here's how you would query it. Here's perspective questions. Here's how I would write the SQL. And then I asked AI, says, is there a better way of writing the SQL? Because my SQL skills are a little rusty. I used to be really, really good at it, but I haven't touched it really hard in about 10 years. But in any event, it was close. But at the end of the day, I wound up having a really good agent that knew this database intimately, inside and out. It knew the schema, and it could take almost any perspective question that you had at it, and it would tell you straight up before you even ran the query. It knew enough whether or not it could answer the question. And it would just respond, I'm sorry, you don't have enough information. Maybe if you provided X, Y, and Z, that way it knew that it could create a proper query to get a good result, because I also put some metrics of acceptability of what it is. And I told it, don't, you know, I'm going to paraphrase here. I'll give you the exact prompt, but basically don't try to be a dog and try to please me. I want a good quality answer. If you can't give me a quality answer of 65% and higher, do not answer the question, politely decline. And so I was able to get it to accurately, at least long enough to do that. And that's why I was kind of asking that question earlier. So I really found the results that you had really interesting, because a couple things you said really surprised me. So I was aware that the volume of data just is not a good thing, especially if it's not unique enough data, because all it does is repeat the vectors. And if you don't have enough, and the reason the results got worse, at least from my finding, is that there's too many similar vectors and it doesn't know how to lock onto anything. Because if you think of that three-dimensional Rubik's Cube where it tries to do height, width, and depth to go where into the cube it needs to get to the point of those three perspectives to get to the data, it's just, there's a cluster bomb in this one area and everything is so sparse everywhere else. That's why it hallucinates, because it doesn't know what to do with it. And so it flips out. So that part I knew, but yeah, so really, really great and interesting stuff here. So how would you suggest, if you're a leader in a company and you're off doing explorations, and there's different types of explorations, where might there be a good investment of time and resources and money where companies should consider going down the path that you go? Like what is a good use case, if any, for them to do that? I know you said large language models in the context of what you were doing with it, but is there an applicable use case to where this may be something of at least worth exploration for their own investment of time and money?
Yeah, I mean, there's plenty of tools out there for conversational analytics. And, conversational analytics is only part of the experience, right? If that is all that you're looking for, there are plenty of tools out there. And what I'd always recommend, and I always recommend, is go talk to an expert. Somebody who has been around and done a lot. And that's David and I's day job, because they're going to be able to tell you the cheat code. So there's many ways to go to point A to point Z, right? If you would like to take the express route, you'll want to talk to somebody that has some wisdom. If you want to meander and go from A to B, B to C, et cetera, et cetera, et cetera, doing individual explorations works really well. But, it comes down to getting a good understanding of what you're trying to do. And that starts with understanding what business metrics are you trying to change. Are you trying to save people's time? Are you trying to generate more sales? Are you trying to reduce how much headcount doing something? There are lots of different tricks to the trade. Now, you can go out there and you could start evaluating tools and, throw the spaghetti in the wall until one noodle sticks. Hey, that does work if you put enough time and attention to it. But it comes down to what you want to do and what you want to accomplish, and that will give you the best chance to succeed. And lots of options out there, and that is the biggest thing that I hear from people. Sean, which way should we go?
Yeah, that's
pick a road and go on it.
That's the answer, of the golden question of the hour. A lot of it's experimentation too, but there's always places to start, and don't boil the ocean. Just start with a small, like Sean did a lot. Maybe you start off with at least just enough to get a taste, get a sampling, get a little bit of everything going here, and then come back and circle back, and then grow your data set. Just make sure you're documenting everything along the way, so you have these repeatable steps. That way, if somebody else needs to come in, join the project later, replace somebody, obviously priorities change, you'll have a way to move this particular thing forward. But anything else to add before we wrap up?
No, man. Again, as always, reach out. If you have new torturous use cases you want us to talk about and explore, please let us know. I love doing this stuff. It does not take a large amount of time. Nope. And now that I have a dedicated GPU, I'm going to be able to do a lot more.
Excellent. Well, you heard that. Sean's now taking your requests. And speaking of requests, you can send them in via this forum, via our brand new website. So check us out at transformationleaderspodcast.com. Click on the contact button, fill out your form, and put Sean's GPU to test. Now, I have one too, so if he gets overloaded, we can offload this over to my machine. So happy to join in the bandwagon and play along. But until next time, we'll see you next Wednesday. This is that's it for our show this week. Thanks a lot, everybody.
Thanks.
Bye-bye.